Chapter 8 is about air masses, and we're going to be looking at what characteristics does the air have. Is it going to be warm? Is it going to be cold? Is it going to be very cold? Is it going to be humid or moist? Is it going to be dry? These are the characteristics that we look at an air mass. It's going to tell us, one, where the wind is coming from, and we find that out by wind flow around high pressure and low pressure. Remember, counterclockwise wind flow around low pressure, clockwise wind flow around high pressure. We're going to go back to chapter 6 in just a second. So when we're thinking about air masses, okay, we have to look at, is it coming from a moisture source or is it coming from the land source? And when we look at these land versus moisture sources, we're going to be looking at a couple of different things. So just very quickly, here's the winter weather pattern. We have very cold, very dry air, which is continental Arctic. And then we have warm and humid air, which is maritime polar. You can see the continental Arctic comes from the dry areas of the North Pole. Continental polar, another dry landmass. Continental land, maritime, which is water. So is the wind flow coming in off the water or off the land? If it's from a water source, it's going to be moist and humid. If it's from a land source, it's going to be dry. And we can figure out these wind flows and the type of air masses that we're going to get by the location of high pressures and low pressures. Remember in chapter 6 when we were talking about the wind flow around high pressure and low pressure. So what we watch here is, okay, here's low pressure, counterclockwise wind flow. Counterclockwise wind flow around low pressure, okay? So if Long Island was over here, this was Long Island, and low pressure was to your west, your wind flow would be generally from the south, okay, kind of southeast. That's off the Atlantic Ocean, so that would be a moist ocean water air mass, okay? So if low pressure was to your west, your wind flow is generally going to be from a southerly direction. That is typically a maritime tropical air mass, okay? If Long Island was over here, near high pressure, your wind's coming from this direction, north to northwest. Okay, so if high pressure was to your west, our wind would be from the north. And this northerly wind here, this would be more of a continental polar air mass. So if high pressure is to your west, from Long Island, we have a northerly wind, and it's a continental polar air mass. It'll be dry and it will be cold. Okay, so understanding the wind flow. Wind flow around high pressure is clockwise. So you can see this would be a clockwise wind flow around Long Island. And that would give us a cold wind from the north. That would be continental polar. As opposed to if low pressure was to our west, again, if here was Long Island, you get the idea of what Long Island looks like, we would have a south to southwest wind here, and that would give us a MT air mass, or maritime tropical. Maritime tropical. If low pressure is to your west, low pressure, cyclone, cyclonic wind flow, that would give Long Island a maritime tropical air mass. In the same regards, if Long Island had an anticyclone or high pressure to the east, okay, this would be the east over here. This is north, south, west, you get the idea. Wind flow around high pressure would be clockwise. So this would be a south to southeast wind. That would also be a maritime tropical air mass. So remember, your wind is dependent on the storm center. Wind flows from high pressure to low pressure. So understanding the direction of the wind will give us an idea of what air mass that we have. So low pressure to the west of Long Island, a southerly wind, maritime tropical. Low pressure is a cyclone, high pressure anticyclone. So if you had an anticyclone to the east of Long Island, you have a south to southwest wind here as well, south, southeast, southwest, maritime tropical. So you can see you could have a similar wind flow or air mass depending on where low pressure is. Okay? Now, if you want a cold air mass on Long Island, let's say here's low pressure right here. And if Long Island was over here, that would be a northeast to northerly wind. This would be our nor'easters. This would be a northeast wind, a 45-degree wind, as the wind flowed around low pressure. So this would be for us a northeasterly wind. That would be a maritime polar air mass. Maritime polar air mass. Cold, cool, moist, humid, maritime polar air mass. So nor'easters are maritime polar air masses for Long Island. High pressure, anticyclonic flow. If Long Island is over here, that's a cold wind flow for us. If Long Island was over here with high pressure, southerly wind, that would be a maritime tropical. So from the same system, you could have similar wind flows, okay? But it all depends on where you are to these pressure centers, and especially to the storm center, because wind flows from high pressure to low pressure. So you need to understand where you're located around higher pressure and lower pressure. So understanding the wind flow is low pressure to your east, is low pressure to your west, is high pressure to your east, is high pressure to your west. And understanding that wind flow, so if we were to look at this weather map, if there was low pressure right here, that would be a maritime polar air mass. That's our nor'easter, okay? And this would be winter. So you would have cold air coming in this way, maritime polar air coming in this way. That's where we get our major snowstorms from, this maritime polar air mass. If high pressure was to our west, if this was high pressure here, we would have cold continental polar air mass. So if high pressure was to our west or northwest, we would have a continental polar air mass, cold and dry. This would be a 330 wind, 300-degree wind, the north to northwest wind over here. That would be our cold weather conditions. So this is where if we want cold and dry, if we want cold and moist, we need low pressure out near here, and that's where we get our maritime polar air mass from. Now, if we were to take a look at, if we want warm and humid conditions, like if we were to take a look at summer, so here's our summertime pattern. You know those days when it gets really hot and humid? High pressure's here. High pressure's there in the summer. And what happens is high dew points, high moisture, wind flow like this. That's where we get our warm and humid sticky days where it's uncomfortable. You step outside, you start sweating. Those are our hot and humid days. Okay? The really hot scorcher days where it's dry, that only really occurs in the plains where they can get temperatures 110, 115 degrees. Continental tropical, that's a hot and humid air mass. Only happens during summer. In our summer, our predominant wind flow is from the southerly direction, and most of our summer on Long Island, we get warm and humid air masses. Occasionally during the summer, we do get a little bit stronger of a cold front where high pressure sets up here and wind flow goes like that. Okay? Our predominant wind flow in the summer is from this maritime tropical air mass that comes in from the south. So that's why we stay so warm in the summer. And then during the winter, our predominant air mass in the winter is this cold Canadian high. And the reason why is that North Pole high pressure suppresses southward. That cold Canadian high presses southward. So we get cold, dry air in the winter, warm, moist air in the summer. The subtropical high impacts Long Island in the summer. The polar high impacts Long Island in the winter, except when we get major storms, and that's low pressure out over here, northeast, nor'easters. Our nor'easters are a maritime polar air mass, okay? So I just want to remember that understanding the wind flow around high pressure and low pressure, understanding where you are in reference to high pressure or low pressure. Are you east of high pressure? Are you west of high pressure? That'll give us an idea of potentially of what we can expect as we're looking at the wind flow. So take a look at the wind flow: continental polar, continental Arctic, maritime polar, maritime tropical. Notice maritime off the water is warm and humid. Maritime polar, cool, or it can be cold and humid or cold and moist. Our wind flow predominantly in the winter is this continental polar air mass. Our wind flow predominantly in the summer is this maritime tropical. Continental tropical, hot, dry, typically only occurs in the summer months. Continental Arctic occurs only in the winter months. So there's two air masses that only occur during their proper seasons. Continental Arctic in the winter, extremely cold, extremely dry. Continental tropical, extremely hot, dry, and those occur in summer. So Arctic in the winter, continental tropical only in the summer. And you can see where the maritime polars are: cold, cool, moist, humid. Maritime tropicals, Pacific Ocean, Atlantic Ocean. So understanding, here's that table 8.1 going over the source regions and the parameters. Make sure you're understanding the wind flow from chapter 6. Wind flows counterclockwise with low pressure, clockwise with high pressure. So remember, understanding where are you with high pressure or low pressure. Are you over here? That's a southerly wind for Long Island. Is Long Island over here? That would be a northerly wind for Long Island. Are we over here near high pressure? That would be a southerly wind. So understand where you are in reference to pressure systems. Always understand you have north, south, south, east, and west. Sorry about my chart here. So this is east over here. So understanding, are the storms north, south, east, and west, and the wind is always the direction it is coming from. Always the direction it is coming from. So make sure you kind of look at chapter 8 and go over the air masses. Take a look at that previous video. Chapter 8 is on the second part of chapter 7. Make sure you go over that. Understanding that global wind flow. Look at chapter 6 and make sure you understand how everything ties together of how is the wind flowing around high pressure and low pressure. Notice the arrows. The arrows flow into at the surface with lower pressure and out of. Remember this diagram. Notice those arrows. Wind flows into low pressure at the surface, out of high pressure at the surface. Above the ground, wind goes up and out with low pressure. Wind converges, then goes down. That's the substance. So that's one of the things. If you can remember this chart of the vertical wind flow and the surface wind flow and a loft wind flow, you can get an idea of what the direction the wind is flowing. And this wind flows all because of the pressure gradient force, the Coriolis force, and friction. Pressure gradient force is the wind that flows from high pressure to low pressure. Coriolis force deflects the wind to the right, and friction changes the speed and the direction of the wind. So friction does two things. So make sure you understand all the wind flows. Go over the course syllabus. Take a look at chapters 6, 7, and 8, and your test 3 is coming up soon. So if you have any questions, please send me an email. We can go over it, and we'll go over it when we do a live review as well, or watch some more of the videos. If you have any questions, let me know. All right, everyone, Professor Hoffman going over chapter 8. Have a great day.